we have finished the sections on the definition of externalities and what is the impact of externalities on social welfare, right? Whether or how the negative externality is inefficient and how the positive externality is efficient. And we learned that if there is this negative externality, then the market outcome will generate a very large quantity, or the market quantity will be too large compared with this socially optimum quantity. And then in the case of positive externality, we learned that the market outcome will be too small. That is, the market quantity is too small compared with the socially optimal quantity level. And we also know that in the case of negative externality, the government can impose a tax on the firm. Then the firm will internalize this negative externality. So the market outcome with tax will become optimal. And then in the case of positive externality, we learned that in this case, the government can actually provide some subsidy. Right? In this case, the demand curve of the social value and the demand curve of the private value, these two demand curves, they will just overlap with each other if the subsidy is properly implemented. So in this case, the market outcome with subsidy will become optimal again. So today, let's continue this discussion. That is, we want to understand how public policies can regulate externality. Obviously, the reason why we need public policies is because we have learned in the previous chapter that market outcome is inefficient. So we need some policies to improve the efficiency of the market. So we will basically consider what government can do, right? If there is externality. Generally, we can categorize government responses into two categories. The first is this command and control policy. That is, the government will just tell, right? For example, in the case of in the case of negative externality, the government would just tell the firm, hey, you cannot pollute. Or the government could impose a upper bound. The government can just tell these firms, each of you guys can only pollute, let's say, 300 tons of water, something like that, right? So this is a command and control approach. The second policy is this market-based approach. That is, government will use taxes, or later you will see the government could also use some permits. So government can use taxes and permits to modify the incentives of firms. And in this case, negative externality can be dealt with, can be regulated with these market-based approach. So let's see. So basically, we will want to compare these two different approaches, right? We want to think generally which approach is preferred. Should we prefer command and control approach, or should we prefer the market-based approach? So let's first get an overview on this command and control approach. So it's really just about regulation, right? So the government will basically regulate these firms who pollute the air or water, right? For example, the government can say any factory can only dump 1,000 kilograms of chemicals into the river per day. So in this case, the government sets a upper bound. No factory can exceed this upper bound. And if a factory violates this upper bound, then the government can impose a much larger penalty. Or the government can just directly tell these factories, you could never dump chemicals in the river, right? That's a more extreme form of regulation. And you can very quickly see that implementing such a regulation policy is actually not easy. The reason is, first, you might think, okay, we should protect the environment, so we should prohibit all factories from polluting the environment. But you can see that from the economic development perspective, this is not realistic, right? You have to let these factories operate to do their business. And in the process, there got to be some sort of pollution, right? So now the question becomes, if prohibiting all polluting activity is not realistic, what the government can do using this regulation approach? So obviously the government can impose this, right? The government can impose a upper bound, a maximum level of pollution, right? Now, this seems like a quite easy to implement policy. But if you think about it, if you think about the detail, it actually becomes quite complicated, right? Think about this. If you look at this previous example, we said the government can tell these firms, these factories, any factories can only dump 1,000 kg of chemicals. However, how do you know 1,000 kilograms is the right number? Why not 800 kilograms? Why not 1,500 kilograms, right? So basically, coming up with this number is hard because the government has to know the details on specific industries to correctly find out the optimal level of pollution. However, you could imagine that a lot of times government officials, they lack the ability to truly understand the details in each different firms, right? Okay, you might wonder, okay, do we have other regulation method? Well, yes, we do have some method. For example, the government can tell each factory, hey, you have to use a certain technology, right? Use this clean technology to reduce your emissions. But again, we will get into the same problem. That is, government officials are not the best person to understand the exact clean technologies which need to be implemented, right? So you can see that there is this information problem. That is, most likely government officials, they know little about firms they want to regulate. Right? So it's hard for them to come up with the correct number. That is, what is this upper bound, or what type of technologies these firms should implement. So now let's think about the second approach, right? This market-based approach. So basically, we have talked about this, right? In the case of a lot, in the case of the negative externality, we learned government can actually use taxes, right? In that example, we learned the social cost is higher than the private cost because of pollution. So, okay, let me go back to the picture. So, in the case of this aluminum factory, we learned the social cost is higher. So we said the government can impose tax if the tax is exactly the size as this distance between these two different supply curves. Then the tax can push the private cost curve up to overlap with this social cost supply curve. So in the case of with tax, the market outcome will actually be optimal, right? So it's pretty easy to understand. Okay, let me go to this section on market-based policy. Okay, so the corrective tax, right? The corrective tax is the tax which is imposed to correct the effect of negative externalities. So in the case we just mentioned, in the aluminum factory polluting air case, the tax imposed on this aluminum factory is a corrective tax. The corrective tax is also called Pigovian tax because this kind of approach, this kind of method, is proposed by this guy. Right? Now you might wonder what's the ideal tax, right? What's the best tax we should impose to restore the market outcome to the efficient level? Well, we discussed about this, right? So in the case of negative externalities, you would want the tax to be the same size as the distance between these two supply curves. And then in the case of positive externalities, again, you want the subsidy, right, to be exactly the same as the distance between these two demand curves. Again, you can see that this is still a hard approach, right? Because think about this: if you're a government, if you want to impose a tax or a subsidy, if you want to get the best optimal result, you have to figure out what is this distance. It's still not easy, right? But theoretically, you can see that at least theoretically, if the government has this knowledge, then theoretically the market can give us the optimal result, the efficient result. Okay, great. So what is the economist's view on these two different approaches, right? Market-based versus command and control. Well, you can imagine that basically economists generally believe in the power of the market, right? Because for the market, the force of demand and supply will most of the time give us the best result. Right? So you can imagine that generally economists, they prefer market-based solution. Because if you think about the command and control, this regulation approach, this approach essentially dictates the level of pollution or the type of clean technologies which needs to be implemented in different firms. You can consider this kind of regulation approach as a central planner solution, right? So generally, economists prefer market to central planner. Okay, let's see a very simple example. It's an example about a paper mill and a steel mill. So both are polluting the river. So let's say a paper mill and a steel mill are each dumping 500 tons of pollutant in a river every year. Now, we have two kinds of approaches to solve or to reduce this pollution problem. Let's say this first approach, solution one, is using this command and control approach. So let's assume Environmental Canada, which is the agency regulating environment, right, tells each factory to reduce its pollution to 300 tons. And then the second solution is the market-based approach. So Environment Canada can just impose a tax on each factory of $50,000 for each ton of pollutant it emits. Right? So for each 1 ton of pollution, the factory has to pay $50,000. So if you compare these two approaches, you can see that generally we will prefer the second market-based approach. Now, what is the reason, right? What are the exact reasons we would want to use this market-based tax approach? Well, the reason is because first, a tax is just as effective as a regulation in reducing the level of pollution. So basically, the government can achieve any level of pollution it wants by, sorry. Basically, government can achieve whatever level of pollution it wants by setting the tax at the appropriate level. So what does this mean here? Well, it means something like this. Let's say you're the government. You're trying to find out the correct tax to regulate the level of pollution. So you can imagine that there is the demand curve, right? So this is the demand curve for pollution, right? That is firms' demand curve, because the firms, if they engage in their productions, then they will generate pollutants. So they will want to, or they will have to pollute the river. And then, so this is basically the demand curve for pollution. Let's say at the tax of 50,000, right? Each firm will want to pollute 100 tons. Then at the price of, let's say, I just give a random number. Let's say $70,000. The firms will only want to produce 80 tons. Now you can see that if the government wants to make sure every firm will only produce 80 tons, then government should impose this $70,000 tax, right? And now let's say if the government wants to make sure the each firm would just produce 100 tons of pollution. In this case, you can see that the government would impose a lower tax, $50,000, right? Obviously, if you move along this demand curve for any level of pollution level, you can find a price. You would just use this price as your tax, right? So that's why if the government understands firms' demand curve for pollution, then government can achieve whatever level of pollution it wants by setting the correct tax. Now, reason 2, the tax would reduce pollution more efficiently. Why? Well, the reason is really because of firms' differences in their technologies. So let's say paper mill, right? It can reduce pollution at a lower cost than the steel mill. Now, if you're given this information, if you understand this technological difference, you would imagine that, right? The best result is the paper mill should reduce more pollutions. It's really simple. It's really simply because it has better technology in reducing pollution. However, you can see that in the command and control approach, the government regulates the paper mill and the steel mill. The government tells these two firms, hey, you have to reduce your pollution by the same amount. Now you can instantly see that this does not make sense, right? And then you can see what is the effect of imposing a tax. If you're imposing a tax, then the paper mill and the steel mill can optimally choose the best level of pollution they want according to their different technologies. So for the paper mill, it has better technology. Then in this case, the paper mill would think, okay, I have better technology, so it's better for me to use my better technology to reduce more pollution because I can save some tax from pollution, right? And now think about the steel mill. We assume steel mill has worse technology in reducing pollution. So now the steel mill will think, okay, I have worse, more costly technology in reducing pollution. So for me, maybe it's better to just reduce pollution a little bit and I will just pay taxes because for me, reducing pollution even more will cost a lot because I have terrible clean technology, right? So you can see that this market-based approach, right, gives each firm the opportunity to make their optimal choice to determine what level of pollution they exactly want, right? So this has very nice incentive effect. Okay, reason 3. Corrective taxes are better for the environment. This is an interesting result. If you think about this, it does make sense. First, under this approach 1, this command and control approach, Environment Canada basically tells each firm, hey, you have to reduce your pollution and the maximum pollution you can generate is 300 tons. Now, this has some incentive effect. That is, after reducing the pollution to less than 300 tons, no firm would have the incentive to reduce further the pollution, right? So it basically means that if the government imposes the first solution, then the best result is each firm will just generate 300 tons of pollution, right? What about the second approach? Well, the second approach imposes taxes. Now you can imagine that some better things can happen, right? So let's say we know the steel mill has this worse clean technology. So it has to pay this it has to pay this higher tax because it is optimal for this firm to generate a higher level of pollution, right? In this case, potentially, this steel mill will think, okay, the tax is pretty high for me. Maybe I should invest more in this clean technology. So you can imagine that by investing more in technology, the steel mill will have better clean technology. And because of this result, the steel mill will actually want to reduce its pollution level furthermore, right? So you can see that, again, this is a very nice incentive effect. That is, given tax, the firms, they could optimally think about how to adopt better technology in reducing pollution, right? And in the first solution, after reducing the emission to 300 tons, firms, they don't have any further incentive to further reduce the pollution level. Now let's examine a third solution. Remember, we basically talk about two kinds of solutions. The first one is the command and control. That is, each firm cannot emit more than 300 tons of pollution into the river. And the second one is the market-based. And in this case, Environmental Canada can impose the tax on each factories. Now, Environment Canada can also adopt a different market-based approach. It's the tradable pollution permits. Right? How this works? Well, let's examine this third solution. So let's say Environmental Canada gives permits of 300 tons to each factory, and then let them trade permits with each other. So you can see that the permit of 300 tons, basically if a firm has this permit, then it can generate up to 300 tons of pollution, right? So this is the purpose of the permit, or the function of the permit. But think about this. Let's say each firm has this permit of 300 tons. And let's say the firm, they can actually trade permits with each other. That is, maybe for some firm, right? It has very good clean technology. So for this firm, it's always better to reduce pollution level instead of using this permit. So in this case, maybe the firm with better clean technology will want to just sell some of the permits to the other firm which has worse clean technology, right? So in this case, we know that if we continue to assume the paper mill has better clean technology and the steel mill still has this worse clean technology, then you can imagine that instead of using up all the permits, the paper mill may just want to use its better technology to reduce the pollution, and then it could sell these permits to the steel mill, right? Now, why this is a market-based approach? Well, the reason is because you can imagine that in the end, these two approaches will generate the same result. So let's see how this actually works. Let's say you're the government and you have the understanding of the firm's demand for pollution rights, right? And the horizontal axis is the quantity of pollution, and the vertical axis is the price of pollution. Now you can see that given corrective tax, given imposed tax, you can see the number of quantities of pollutions. Note that quantity of pollution equals number of permits. So this basically says if the government understands the demand curve, then given tax, it can predict how many number of permits will be demanded from the firms. Now, if you look at the right-hand side, it basically means, again, we have this same demand curve. It means that if the government issues this quantity of permits, then the government will actually see what is the price of pollution in the market, right? That is, in the right-hand side, given the quantity of pollution permits, then we will get the same result as imposing corrective tax, right? I mean, it's really a very simple application of demand. It basically says that if you have this demand curve, given price, hey, I can tell you quantity, right? And same thing. Given quantity, I can tell you price, right? So it does not matter whether you wanted to tell me price or quantity. They're the same as long as you tell me what is the demand curve. Okay. We still want to understand whether this tradable permits is a good policy. Well, it is. There are two reasons. The first reason is this tradable permit policy would definitely make the owners of these two factories better off. Why? Well, it's because they are voluntarily trade with each other. So the thing about trading is a buyer will only want to buy if there is consumer surplus. A seller will only want to sell if there is producer surplus. So if you can see a transaction happening, then you can guess there gotta be some consumer surplus and producers surplus in the process, right? So you can see that in this tradable pollution permits example, if two firms that are trading with each other, that is, there is a buyer firm, there is a seller firm, then they are definitely getting some profit, getting some surplus from their trading with each other. So this basically means once they trade with each other, they become better off. Now, what is this second reason? Well, the second reason says that the initial allocation of pollution permits does not matter. Why does not matter? Well, simply put it, it's really because if there is a market for trading permits between different firms, how you allocate pollution permits initially into these firms does not matter, because you can imagine that if you allocate the pollution permits, let's say into one firm, then you can see that in the end, other firms will be able to buy pollution permits from this one firm, right? And then let's assume you would allocate the pollution permits equally between different firms. Again, you can imagine that those firms which can reduce pollution more easily will be willing to sell, right? And those firms which can reduce pollution at a higher cost with worse clean technology, these firms will be happy to buy permits from other firms. So in the end, if the firm can trade with each other through firms' transactions, in the end, the trading or the tradable pollution permits will be allocated optimally. Right? So the initial allocation is not important. Okay, let's see, what is this? So we have a glue factory and a steel mill. They both emit smoke, which contains a chemical that is harmful. Describe 3 ways the town government might respond to this externality. Well, clearly we have learned 3 different methods. Right? The first method is command and control. Right? So the first one is command and control. That is, the government can use a regulation approach. For example, the government can say both of these factories cannot emit any smoke. Or you could say the government tells these 2 factories the daily highest amount of smoke you can emit is 100 tons. Right? Now the second one is this corrective tax. For example, the government can say, if you emit smoke into the air per ton, I have to charge you $10,000. And the third is tradable tradable permit. For example, the government thinks the acceptable level of pollution is a total of 1,000 tons of smoke per year. So the government can give, let's say, 500 tons of permit to the glue factory. The other permit of 500 tons of smoke to the steel factory. And then the government can tell these two factories, hey, you guys can trade with each other. In this case, you can imagine, let's say, if glue factory has better clean technology, for example, possibly in the end, this glue factory will only use 250 tons of permit. And then the permit of the other 250 tons, well, this glue factory will just sell this part of permit to this steel mill factory. So in the end, the glue factory will use the permit of 250 tons, and the steel mill will use the permit of 750 tons. Right? So this basically means the initial allocation of the tradable permit does not matter, as long as these firms can trade with each other. Okay, now let's discuss the private solutions to externalities. So basically, we just discussed the public solutions or the government solutions to externalities. And you might wonder, do we always need government to step in to solve the externalities problems? Well, it's not. Sometimes, under some cases, private parties, that is, different people, then they can actually solve this externalities problem themselves. So this is a famous result proposed in this Coase Theorem. So Coase Theorem basically says if private parties can bargain without cost over the allocation of resources, they can solve the problems of externalities on their own. You can see that this result only holds under a very important assumption. That is, the private parties can bargain without cost, right? Without cost. And you can imagine that if there is bargaining cost, then possibly private parties cannot solve externalities themselves. And under the assumption of with cost, we need government, right? And you can also see that the assumption of without cost is actually quite unrealistic, because you can imagine that nearly in any bargaining, there will be cost, right? Okay, first let's see this example here. So let's say there are two people, Jack and Jane. Jack has a dog whose name is Spot, who barks and disturbs Jane at night. And Jack gets 500 of happiness from the dog, and Jane bears a 800 cost from the barking. Now, what is the efficient outcome? Well, you can see this. So we can calculate the total surplus with dog and without dog. Right? So the total surplus with dog. In this case, you can see that Jack gets 500. Jane gets minus 800. So it's 500 minus 800, which is minus 300. Now, what about the total surplus without dog? In this case, you can see that Jack loses 800. Sorry, Jack loses. Jack loses this 500, right? So it becomes 0. And Jane does not need to bear the 800 cost from the barking. So it's again 0. So this basically means from the perspective of the social total surplus, without dog is a better result compared with dog. Right? So we should get rid of the dog. Okay, clearly this is a weird example, right? Because everybody loves dog, but I guess I copied this example from the lecture note, so I will just use this example. Okay, now let's see whether they could achieve this efficient result through bargaining. That is, whether they can solve these externalities themselves if they could bargain with each other without cost. Right? So let's see. There are two cases depending on the so-called property right. So first, let's assume Jack has the right. That is, Jack has the property right. So Jack has the right of keeping a barking dog. Now, how Jane can bargain with Jack? Well, let's assume Jane decides to pay $600 to Jack to get rid of the dog. Now, look at this. Jack only gets $500 from the dog, and Jane pays $600 to get rid of the dog. So we can see that in this case, Jack's gain, what is Jack's gain? $600 minus 500, which is 100, right? Now, what about Jane, right? So Jane pays 600. So Jane pays 600. However, Jane has to bear a 800 cost from the bargain. So after paying this $600, Jane does not need to pay this 800 cost, right? So in this case, you can see that Jane will get this $200 benefit. That is the difference between 800 and 600. So this basically means both Jack and Jane, they will be better off. So they will get rid of the dog. That is, through bargaining, Jane and Jack can achieve this efficient outcome of getting rid of the dog. Now, what about the other case? Let's say Jane has the right of a quiet environment. So in this time, you can see that because Jane has the right, then Jane won't need to pay Jack any money. Jane can just knock on Jack's door and tell him, hey, you have to get rid of the dog, right? And in this case, you can see that Jack definitely becomes worse off. However, Jack has to get rid of the dog because Jane has the right. So you can see that Jack's loss is minus $500. What is Jane's gain? Right? Jane will gain $800, right? Because Jane does not bear this 800 cost from the barking after getting rid of the dog. So you can see that there is a net gain of $300. Again, the important thing is, in the second case, still through bargaining, right? Jane and Jack can achieve this efficient outcome. Now, what you can see here is another important result. That is, the initial allocation of right does not matter, right? You can see that we have discussed two different cases. In the first case, Jack has the right of keeping a barking dog. In this case, we will have the efficient outcome. Second case, we have the opposite allocation of right, because now Jane has the right of a quiet environment. And again, under this different allocation of right, we can see that we will again achieve this efficient outcome. Right? So basically this implies if these private parties can bargain with each other, right, without cost, then a efficient outcome can be achieved no matter what is the no matter what is the initial allocation of rights. A third comment is about the welfare effect. Well, you can see that you will always achieve this efficient outcome, no matter how you allocate the initial rights, right? However, you can see that the allocation of right will affect each individual's welfare. So you can see that in the first case, right? In the first case, Jack has the right. So after getting the dog, Jack will get $100. And in the second case, Jane has the right, and Jack will just lose $500. So Jack is far worse off in the second case. This is easy to understand because in the second case, Jane has the right. So by the same reason, you can see that in the first case, when Jack has the right of keeping the dog, then Jane will only get $200 of benefit. But in the case of, but in the second case, when Jane has the right of a quiet environment, Jane will get the $800, much larger benefit, right? Again, it's really because Jane has the right. So this essentially implies that in the bargaining process, the initial allocation of the rights will affect individuals' benefit or individuals' welfare. Okay. Yeah, maybe this is worth repeating. To sum up, the Coase Theorem says that private parties can private parties can solve the problem of externalities among themselves through bargaining if there is no cost. And the initial distribution of rights does not matter because the private parties, they can always reach a bargain in which the outcome is efficient. Okay, let's look at this exercise. So let's assume 1,000 residents of Green Valley value swimming in Blue Lake at $100,000. And there's a factory which pollutes the lake river. And the factory needs to pay $50,000 to remove or to eliminate the pollution. So let's describe a coast-like private solution. Well, what you can see here is basically these residents, they could talk to the manager of this factory, right? For example, these residents can actually pay $60,000 to the factory. And you can see that, okay, let me write this down. Let's say if the residents, right, they pay $60,000 to the factory. Right? So you can see that so if you look at these numbers, you can see that even after paying this $60,000 to buy this non-polluting equipment to reduce pollution, you can see that the surplus, right? The residents' surplus is $40,000. And what is the factory's surplus? Well, the factory gets $60,000, but it only needs $50,000 for this non-polluting equipment. So you can see that the the factory's surplus is $10,000. So you can see that if these residents bargain with the factory over purchasing this non-polluting environment, then both the residents and the factory could be better off. Right? So this is a Coase-like private solution. Now, can you think of any reason why this solution might not work in the real world? Remember when we first discussed Coase Theorem, we said there is a important assumption, that is no bargaining cost, right? So only when private parties they can bargain without cost, then this bargaining can solve the externality problem. The solution can be efficient, right? Well, clearly, if there is cost in the bargaining process, then possibly they cannot achieve this Coase-like private solution. So let's say it's too expensive to hire a lawyer to finalize the contract, right? So basically in the process of bargaining with the factory, when they were trying to sign a contract over the transfer of money from the residents to the factory over the purchase of the equipment, right? When they need a contract, they have to hire some lawyer. If we assume lawyers are super expensive, then you could see that the contract can never be finalized. So they cannot achieve a Coase-like private solution. In this case, we're actually examining the effect of transaction cost, because the cost of hiring a lawyer is a transaction cost of signing the contract. So you can see that large transaction cost can prevent this Coase-like private solution from happening. There is always this potential coordination cost. The reason because you have 1,000 residents. So you have to coordinate all of these residents to negotiate with this factory. For example, if these residents they need to pay $60,000 to factory, then potentially for each resident they have to pay $60. And you can see that there is this huge coordination efforts which are needed to collect these payments, right? Potentially they have to form a committee, and then they have to have a voting process to select some representatives of these residents to negotiate with the factory. So it's a complicated process, right? And you can imagine that if you have 1,000 residents, then potentially there could be some problem during this process. So maybe these 1,000 people, they cannot coordinate very well with each other. So in the end, the bargaining could break down because of this failure in coordination between 1,000 residents. Okay. So you can imagine that in the real world, right? Private bargaining usually, always, generally incurs some cost. And because of these costs, private bargaining can fail to achieve efficient result. So now we would want the government possibly to impose some tax, to enact some law, right? We want the government to play a role to push this market into this efficient outcome. For example, in this negotiation between 1,000 residents and the factory, if the negotiation fails because of a failure of coordination between these residents, then the government, right, can just step in and represent these 1,000 residents to negotiate with the factory. In reality, you can see that generally you will have these local environmental agencies, right? So these agencies can pretty much directly negotiate or regulate these factories, which will provide this potential efficient solution. So give an example of a private solution of a externality. And what is the Coase Theorem? What are private economics? Why are private economic actors sometimes unable to solve the problems caused by a externality? Well, if you think about the private solution to a externality, then obviously you have to think about this from your own life, right? So, when I was doing my PhD in the U.S., I had a very loud neighbor who lived, next door. So every time when he was having a party, I had to knock on his door, and I would tell him, "Hey, I am doing my homework. I'm doing my research. Please turn down your volume." So you can see that this is a private solution to a externality, right? There is this negative externality from the loud noise. And then I would bargain with my neighbor, right? So through this bargaining, then this neighbor would listen to me and turn down the volume. And you can also see that the bargaining cost is actually relatively very small because this is the next door neighbor and I know him and he's generally a nice guy, right? So I would talk to him. So after bargaining, we could achieve this efficient result. Now, what is Coase Theorem? Obviously, you can just look at the lecture note. You would know what is Coase Theorem. But it's good if you can remember what is Coase Theorem, right? It basically says private parties, if they can bargain with each other without cost, then they can solve the problems of externalities themselves. And more importantly, besides achieving efficient outcome, the initial allocation of rights actually does not matter. So why are private economic actors sometimes unable to solve the problems caused by an externality? In the lecture note, we discussed, let me think, at least two types of costs, right? The first is transaction cost. The second is coordination cost. There could be some other costs, right? Think about this. In my example, I could knock on my neighbor's door and ask him to turn down the volume. But you can imagine that if my neighbor in the next door is a very dangerous person, right? So maybe I just will not knock on his door, right? Because I would feel if I knock on his door, maybe there could be some severe consequences if the neighbor is a bad person, right? So in this case, you can see that the fear can prevent bargaining from happening, right? Okay, let's see the true-false question. So you can see that this chapter is very conceptual, right? We don't have a lot of calculations. We were basically talking and telling different examples in the lecture. Right? So just make sure you understand these concepts, right? What is the negative externality? What is the positive externality? What is this Coase theorem? and how do you solve negative externalities and positive externalities, right? And why the market-based approaches are generally preferred to the command and the control approaches, right? Okay, let's see the true-false problem. A technology spillover is a type of negative externality. Well, this is obviously false because I mean, it's just common sense, right? It's a technology spillover. So it basically means technology from a firm or a firm's technology gets spilled over to B firm. So B firm will get the benefit from A firm's technology. So obviously this is a positive externality. Organizers of a outdoor concert surrounded by residential neighborhoods are likely to consider the noise and traffic cost when they assess the financial viability of the concert. Obviously, this is false, right? Because if you're the organizer, if you're specifically thinking about the financial viability, right? So you will just want to think whether your concert will make money or not. In this case, we will not consider the noise and traffic cost because these are just external effect imposed on third party, right? Government can be used to solve externality problems that are too costly for private parties to solve. We discussed this, right? We said in this, I mean, in the example of 1,000 residents versus factory, right? We said in that case, if it's too costly for these 1,000 residents to negotiate with the factory, then it's possible they will not be able to achieve this efficient outcome. So now, let's say the environmental agencies can actually help these 1,000 residents, or the environmental agencies can just directly regulate this factory who pollutes the river, right? Okay, so this is true. Equal reduction in pollution among all firms is the least expensive way to clean up the environment. So this is false. The reason is because equal reduction is really this command and control approach. And we learned it's generally better to use a market-based approach, right? Because different firms, they have different technologies. So the optimal way is to let the firm with better technology to reduce more in its pollution and let the firm with worse clean technologies to have more pollutions. So this is false. Both pollution permits and corrective taxes are viewed as cost-effective way to keep the environment clean. Well, clearly we discussed this because in the market-based approach, we discussed two kinds of approaches, right? The first is the permit, the second is the tax. And we also learned in terms of effect, permit and tax have the same effect on pollution. 6. The government can internalize a externality by taxing goods that have negative externality and subsidizing goods that have positive externality. Well, this is easy, right? We have discussed this example several times. So for the aluminum pollution example, government should tax the factory who generates pollution. In the education example, the government should subsidize college students who enroll in college, right? So this is true here. Seventh, according to the Coase Theorem, if private parties can bargain without cost, then the private market can solve the problem of externalities. So this is essentially like the exact version of the Coase Theorem we just learned in the lecture note, right? So this is correct here. 8. The patent system gives firms greater incentive to engage in research and other activities that advance technology. Well, this is like common sense, right? So you should choose true here. So why do we have patent system? The reason is because research and inventions, they have positive externalities. So this basically means this positive externalities will make inventors invent too little, right? So how do you provide incentives to those inventors? Well, you will give them exclusive rights on their inventions, right? So in this case, the patent can give inventors larger incentives to invest in research. 9th, internalizing a negative externality will cause the market supply curve to shift to the right. So this is actually not entirely right. So you have to add some conditioners. We should say internalize a negative externality from sellers. Because in the lecture, at least in this chapter, we only discussed negative externalities from sellers. Obviously, we could have negative externality from consumers, right? Think about the smoke example. In the smoke example, smokers who generate negative externalities are actually consumers, right? So now let's go back to the basic case. That is, we're examining the negative externality from sellers. Well, clearly we have learned about this. If you draw out these curves, you can see that demand curve, this is the private cost supply curve. And if we impose tax, right, then you can see that this will reduce the supply curve. So essentially the new supply curve will be like this. So this will be the new supply curve, for example, the aluminum firm. So this is the new supply curve after imposing tax. So this is correct. Now the 10th problem. The social cost of pollution includes the private cost of the producers plus the cost to those bystanders affected adversely by the pollution. Well, this is right? Because we learned the definition of social cost. Social cost is exactly the sum of the private cost plus the external cost. 11th, firms that can reduce pollution easily will be willing to sell their pollution permits. Okay. This one is actually correct because we discussed the tradable permit. And in that kind of policy, we learned the benefit of tradable permit is firms can trade with each other, right? That is, if a firm has better technology in reducing pollution, the firm will want to sell its pollution permits to firms with worse cleaning technology. So it is true here. 12th, negative externalities lead markets to produce a smaller quantity of a good that is socially desirable, and positive externality lead markets to produce a large quantity of a good that is socially desirable. So, if you recall what we have learned in the negative externality example, you have demand like this, and then you have the private supply curve like this, and social. Let's call this social supply curve as SS, and the private supply curve as SP. Right? Of course, this little s refers to social cost. This little p refers to private cost. Now you can see that clearly the quantity under this private supply curve is just too large, right? So you can see that the statement here is not correct. Of course, you can do the same with the positive externality case. So in the positive externality case, so this is the demand with private value. This is demand with social value. So you can see that social desirable quantity is on the right, and the private market generates a quantity which is smaller than this socially desirable optimal quantity, right? So basically you can see that the second half statement, lead markets to produce a larger quantity than is socially desirable, is not correct. So you should choose false here. Okay, that's for today's class.